Class. Today we are going to discuss further about the relations. Now, as we discussed in the last class about the Cartesian product, now Cartesian product will be helping us to find the relations on two sets. First of all, in the general form, what is an relation? Any relationship between two things, that is known as a relation. Now, if I will talk about sets, sets will be having a relationship, elements will be having some relationship. That means elements will have some relationship. If elements will be having some relationship, that will be paired because they have some relationship. That will be what? That will be a ordered pair. So if we want to describe a relationship between elements of two sets A and B, we can use ordered pairs with their first element taken from A and their second element taken from B. Now, since there is a relationship between two sets, it is called what? It is called a binary relation. Now, definition, let A and B be sets, a binary relation from A to B. It is nothing, it is just a subset of A cross B. The number of subsets we will have A cross B, the number of relations will be there from that number of relations will be there from A to B, because it is nothing, it is just a subset of A cross B, that is Cartesian product of A and B. Next, in other words, for a binary relation we have R is what? R is nothing, it is a subset of A cross B, where R is our relation set from A to B, where we use the notation A R B, small a capital R B. That means small a member of capital A is related to small b member of capital B, and to denote that A comma B ordered pair belongs to R, because if they are related they will form a ordered pair, right? Ordered pair, so it will be belonging to R, or A R dash belongs to B, to denote that A B does not belongs to R, means A is not related to B. Next, we are going to discuss about relations further. When A comma B belongs to R, that means A is said to be related to B by R. A is said to be related to B by R. This is simple. If they are forming a pair, that means, and they are that ordered pair, A comma B belongs to R, that means A is related to B. What it means? A is having some relationship with the B, right? Next, let us say one example for the relationship. First, let P be a set of people, C be a set of cars, and D be a relation describing which person drives the car. First of all, P be the set of Carl, Suzanne, Peter, and Carla. Next, C be the set of cars, Mercedes, BMW, and tricycle. Now, our relation set says Carl and Mercedes is one of the pair. That means if Carl comma Mercedes belongs to set D, which is our relation set, that means relation will be true. Relation is true, that means Carl is driving Mercedes car. Next, Suzanne is also there with Mercedes, means one pair is also there with Suzanne comma Mercedes, that means Suzanne is also driving Mercedes car. Third, Suzanne comma BMW, one more pair is there, Suzanne and BMW, that means Suzanne is also driving BMW because Suzanne was also driving Mercedes. Fourth ordered pair is Peter comma tricycle, that means Peter is driving tricycle. So these type of relationship sets we have to form, or it will be given to us, we have to just find the relationship between them. Now see, this means what? What I told you, Carl drives a Mercedes car, Suzanne drives a Mercedes and a BMW, Peter drives a tricycle. Carla does not drive any of the vehicles. Carla was there one person, right? But Carla is not related to any of the element of C. That means he or she is not driving any of the vehicle. Clear? Next, relation from a set A to B. A relation from set A to B is a subset of A cross B, as we have discussed also. In other words, it is a A relation from set A to set B is the relation between the elements of both the sets, right? Elements are only related, right? Sets are being related with the help of elements. Next, let us see one more example. Let A be equals to 1, 2, 3 and B be the set of 3, 4, 5. Now our relationship says ordered pair A comma B will belongs to relation set if and only if A minus B is odd. Now we will see which elements of A when subtracted from elements of B form odd numbers. That ordered pair will be there. Now let me start with 1 of A. 1 when subtracted from 3 of B, it will give us minus 2, which is not odd. So 1 and 3 will not form a ordered pair. 1 when taken with 4, 1 when subtracted from 4, it will give us minus 3, right? 4 when subtracted from minus 1, sorry, 4 when subtracted from 1, it will give us minus 3, which is odd, right? So if this is odd, right, so this will form one ordered pair, which will be our 1 comma 4. Next 1 comma 5, 1 when 5 when subtracted from 1, it will give us minus 4, which is not odd, so it will not be present in relation set. Now 2 when subtracted from 3, it will give us 1, which is odd, so 2 and 3 will form one pair. Similarly 2 and 4 will not form a pair because they will form a pair but they will not satisfy the condition of relation, that is A minus B must be odd, but 4 minus 2 is even. 4 then 2 minus 5, which is minus 3, odd, so 2 and 4 will also form 2 and 5 will also form a ordered pair. Next 3 and 3, 3 minus 3 is 0, 0 is what? 0 is an even number, it is not odd, so 3 comma 3 will not belongs to our relation set. Next 3 and 4, 3 minus 4 is minus 1, which is odd, right? 3 minus 4 is odd, so 3 comma 4 will also belongs to R. Next 3 comma 5, 3 minus 5 will be minus 2, which is not odd, so it will not belongs to our relation set. So our relation set will be, the relation set is given by R equals to 1 comma 4, 2 comma 3, 2 comma 5 and 3 comma 4. So now relation on a set, a relation on a set A is a relation from A to A. What we are doing? Firstly, we were doing from A to some set B, but now we are doing on same set. Same set means from A to A only. Elements of A are related to elements of A only, right? Next, in other words, it will be a relation on the set A, which is subset of A cross A. Now let me take one example. Let A be the set of 1, 2, 3, 4. They said which ordered pairs are in the relation R A comma B such that A is less than B. So if A is less than B, relation on set A, that means A and A are only related. 1 and 1. If is 1 less than 1? No. 1 less than 2. So 1 comma 2 will belongs to the ordered pair. 1 comma 2 ordered pair will be there. See, 1 and 2 is related. Why they are related? Because 1 is less than 2. Next, 1 and 3. 1 comma 3 will be there in relation set because 1 is always less than 3. So 1 and 3 will be related. Now this type of diagram is known as dot diagram, right? This is a dot diagram, right? This table is not necessary, this is for just for your information, right? But this type of diagram is known as dot diagram. Clear? Now this shows the relation from A to A. Now 1 and 3 are related, 1 and 4 are also related because 1 is always less than 4. Now 2 will be related to 3. Why? Because 2 is less than 3. 2 is neither less than 1, neither less than 2. Right? So it will be 2 is less than 3. So 2 and 3 will be related. So 2 comma 3 ordered pair will belongs to the relation set. Next 2 comma 4 will also belongs to the order set relation set. So it will be a ordered pair. Right? Next 3 comma 4 and then 4 is neither related to any of the element, because 4 is not smaller than any of the element of the second set. So this was our relation, right? So this was our relation set. Now how to find relation set, that you know, but now how many number of elements will a relation set have, that we are going to discuss about. How many different relations can we define from a set A with m elements and set B to set B with n elements. Now we have to define relationship from set A to B. A is having m elements, B is having n elements, and we all know relation is nothing, it is just a subset of A cross B. The number of subsets of A cross B will be equals to the number of relations from A to B, right? So a relation from set A to B is a subset of A cross B. How many elements A cross B have? In the set chapter or in the Cartesian product remarks, we did if A has P elements, B has Q elements, A cross B will have PQ elements. So if A has M elements, B has N elements, A cross B will have Mn elements, right? So if it have Mn elements, how many subset it will have? 2 power Mn, because in the set theory we taken a set of n elements and its subset was 2 power n. So now the subsets of A cross B will be 2 power Mn. So the number of subsets of A cross B will be equals to the number of relations from A to B. So 2 power Mn will be the number of relations from A to B. So this was our today's topic for relation. See it very carefully, observe it, and see in the book. If there is some problem, you can discuss with me anytime. We will discuss further this topic in the class. Thank you.